Another application involving equations in geometry has to do with interior angles, particularly the sum of interior angles in a polygon. So let's review some vocabulary. The first thing that we need to know is what a polygon is. A polygon is an enclosed shape with 3 or more sides. This includes triangles, quadrilaterals, pentagons, and they go up to hexagons, heptagons, octagons, nonagons, and decagons. Beyond a 10-sided figure, like a 10-sided figure we'd call a decagon, beyond there we'd call them like an 11gon. This would be a figure with 11 sides. Or a 12gon, which would be a figure with 12 sides. If we don't know how many sides, we'd call them an n-gon. This is a polygon with n number of sides, and we don't know how many there are. So we put the variable in its place. Another thing that we need to know is what an interior angle is. Interior angles are angles formed at the vertices inside polygon. If we take the shapes that we had above, the triangle, the square, and the pentagon, and we look at the angles that are inside them, the triangle has 1, 2, 3 angles inside of it. It also has 3 sides. If we look at the interior angles of a square, there's 1, 2, 3, 4 interior angles in a square, and there's 4 sides. And if we look at the pentagon, there's 1, 2, 3, 4, 5 angles inside of it and 5 sides. So the interior angles is always going to match the number of sides. That's going to be key when we take a look at the sum of the interior angles formula, which what this says is if you take 180 times n minus 2, where n is the number of sides, you're always going to get the sum of the interior angles. I'm going to do a little bit more of explaining in this in a moment. What you would do is suppose you had a pentagon. I'm going to draw a new pentagon that's here. And what's actually happening is any triangle has an interior measure of its angles as 180 degrees. So if you take one vertex, and you draw lines that are diagonals to other vertices in here, you can actually break it up into triangles. So the way that this works is there would be 1, 2, 3 triangles inside this pentagon, which is why we're going to take 180, and since this would be a 5-sided figure, it would be 180 times 5 minus 2, which would be 180 times 3, because 5 minus 2 is 3, and there's 3 triangles in it. So when you subtract 2, that's actually how many triangles you would get. 3-sided figure is a triangle, and there's just one triangle here. A 4-sided figure, you can actually draw one line across it to make 2 triangles, so 4 minus 2 gives us our 2 triangles. And a 5-sided figure I just did, you would have 5 minus 2, which gives us our 3 triangles. So that's where the n minus 2 is coming from in this formula. We're going to put this to use in a moment. The sum of interior angles formula is typically used to find the sum of interior angles or to find the measure of one angle in a regular polygon. So let's take a look at this in the next few examples. Question 40 says, what is the sum of the interior angles in a pentagon? So the sum is the key word here. The sum of the interior angles means we can use our formula, 180 times n minus 2, where n is the number of sides of the polygon. So if we substitute 5 in for n because a pentagon has 5 sides, we can actually figure out the sum of all those angles. So we would do our arithmetic and we'd get 540 degrees. So the sum of the interior angles in a pentagon is 540 degrees. Moving over to question 41, where it says what is the measure of one angle in a regular pentagon? The measure of one angle in a regular pentagon is the key here. We have to know, first of all, that we're finding one angle, so we're going to have to do something with our sum at the end. The other thing is, since it's regular, all sides are going to be equal. Anytime you have a regular, whatever figure it is, regular pentagon, regular hexagon, all the sides and all the angles are going to be equal. So I should have added that as well. Not only are all the sides equal, but all the angles are equal. Okay, so if we know from our previous example that the sum is 540 degrees, what we're going to do is we're going to take that to find one angle. Since we know that all the angles are equal because it's regular, we're going to take the 540 divided by the 5 angles that are in it, and when we do that, we're going to get 108 degrees. So one angle is going to be 108 degrees, and when we add all 5 108 degrees together, we end up with the 540 that's the sum in this regular pentagon. Question 42 works a little bit differently. The sum of the angles in a polygon is 900 degrees. What type of polygon is this? So this means we're told the sum. We're going to have to work our way backwards. So if we're told the sum, that's going to be our 900 degrees. We're going to use our formula on the other side of the equal sign. And then all we're going to do is distribute. And when we distribute the 180, we get 180n minus 360 equals 900. We're going to solve this by adding 360 to both sides to give us 180 equals 1,260. And then when we divide by 180 on each side, we get n equals 7. But here's our problem. It says what type of polygon is this, not how many sides. So the way that we classify something is by how many sides. A 7-sided polygon is called a heptagon. Let's move on and talk about what would happen if we're given a figure and we know some of the angle measures and some of the angle measures are going to be expressions. I'm talking about question number 45. Number 45 says, what is the value of the variable in the diagram below? So the first thing that we have to do is figure out how are all of these related. All of these angles are inside a triangle, so you might know that that's 180 degrees because it's inside of a triangle, but you may have to go through and use your formula. Because they're all inside of a triangle, you can use the sum of interior angles formula, which is 180 times n minus 2, where n is the number of sides. So if this wasn't a triangle and this was another shape, you would just plug in the number of sides for n. And in our case, it's going to be 3 since a triangle has 3 sides. And when we solve this, we get 180 degrees, which is how many degrees there are in a triangle. Okay, so once we know that they're going to add up to 180 degrees, we can actually set up an equation. We're going to have one angle measure plus another angle measure plus a third angle measure gives us the 180 degrees. So we can fill in the angles that we know. One of them is 45, one of them is the expression y plus 12, and one of them is the expression 2y minus 36. Then I'm going to skip some steps here to save a little bit of time. When we go through and solve this, we would get y equals 53 degrees. That would be the value of the variable in this diagram below. But remember, I skipped a bunch of steps here. Those can be solved by using combining like terms and then solve using inverse operations.